All right, we're going to do a problem here that involves some communication. So we're going to do what's called a count key. So we have an array of a relatively large size, and it's full of values. And our goal is to search the array and search for a particular key k and tell how many times it occurs. So obviously this is not something that we would need to do MPI with unless we have a really big array, but the problem isn't so much the point as the method. So we'll go through a uniprocessor version of it first just to make sure we're all set with the problem. And then the MPI approach that we'll have will be a master-slave sort of approach where our master processor here will create the array, fill it with random values, and then it will divide it into pieces, communicate those down to all the different subprocessors that we have. Okay, the number of subprocessors depends on how we call our MPI process, of course. Then each subprocessor will look through its portion of the array, looking for the values or the key value, and they will then report their results back to the master process, and the master process will then add up all those values and report the final number. Okay, so that's our problem that we're going to solve. Let's take a look at the uniprocessor version of it really quick. So here is our uniprocessor version. Very simple. We're going to pass in the value that we're looking for from the command line. Our array size in this instance for this problem is hard-coded inside the code at 10 million. Okay, and the process will fill the array with values in the closed range from 0 to 10,000, and we're searching for that number k inside there. All right, so looking at our pieces, we just have a simple sanity check at the beginning to make sure that we have the proper number of command line arguments. If we don't, we will output a failure and exit the program. If we did have the proper number of command line arguments, we'll grab k by turning the parameter that came in as a string into an integer, then allocate big N values in an array. Then using the Mersenne twister random number generator, we will fill that array with values from 0 to 10,000 inclusive. And then after that, we'll do our search. And just a linear search, we're looking through the whole array. Every time we find a value that's equal to k, we report or increment our count by 1. And then we print out our results at the end and finally delete the memory that we used for the array. So let's take a look at how that would work. If I execute that program by running that uni.ck program, and let's say I'm looking for the number 5,000, it tells me that it was found 984 times in that array of size 10 million. If I wanted to do something to make sure that this is really working, I could increase my confidence by searching for something that I know that's not in the array, like -1. It's not found in there. If I similarly look for 10,001, that's not in there as well. Any other value between 0 and 10,000 should be in there roughly 1,000 times. Okay? All right, so that's the uniprocessor version of this code. In our next video, then, what we're going to do is show how we would do that with OpenMPI. Okay, so that's next.